Welcome to the Mid-Atlantic Water Program training module on Marcellus Shale and your private drinking water supply. These partners were involved in developing this training module, and the following individuals contributed to this presentation. Marcellus deposits are shale rock formations that may contain significant amounts of natural gas. These deposits are found in New York and Ohio, as well as in the mid-Atlantic states of Pennsylvania, Maryland, Virginia, and West Virginia. The name Marcellus Shale comes from the town of Marcellus, New York, where an outcropping of the Marcellus Shale formation exists. The Marcellus Shale is known as an unconventional gas resource. This means that the gas is held tightly in tiny pore spaces within the shale rock itself. The shale needs to be hydraulically fractured to open these tiny pore spaces and release the gas. The development of horizontal drilling and hydraulic fracturing, or fracking, made exploitation of resources like the Marcellus feasible. One of the first things gas developers want to establish is where to locate the gas wells. Seismic testing is used to help determine the geological characteristics below the surface of the ground. Marcellus Shale seismic testing uses 2D or 3D imaging. In 2D seismic testing, large thumper trucks pound the ground and the vibrations are recorded. These measurements help determine where it is most economical to drill for gas. 3D seismic testing is much more invasive. A grid is laid over the property wherever the lines intersect, and 20-foot deep holes are drilled. Each hole receives a small amount of explosive material which is detonated. The vibrations from the explosions are recorded and analyzed. Before agreeing to 3D seismic testing on their land, owners should know their state regulations and stipulate any setback distances from their water supply. It would be a good idea to consult a professional water well driller or hydrogeologist to determine the amount of water the well will produce before commencing seismic testing. Landowners should also stipulate that the seismic testing boreholes be properly sealed to protect the groundwater from contamination after the seismic testing is done. This is an example of a gas drilling pad. A typical pad will occupy 3 to 5 acres and typically contain 8 to 10 gas wells. Near the top of the photo, water to be used in the hydraulic fracking process is stored in a lined pit. Wastewater produced by the well is stored in the lined pond at the bottom of the photo. Some companies are beginning to use boxcar-like trailer containers instead of pits to store wastewater. The drilling rig is in the center of the picture. The rig will be used to drill a hole that extends below the freshwater aquifers. Substantial excavation and road building is typically needed to develop a drilling pad. The drilling process requires a lot of truck traffic to carry the water, equipment, and sand and chemicals to the pad and haul away wastewater. In addition, each pad needs to have a gas pipeline, termed a gathering line, constructed to carry the gas off the pad and onto market. Fracking is a technique in which typically water is mixed with sand and chemicals, and the mixture is injected at high pressure into a well bore to create fractures, which form conduits along which gas migrates to the well. A typical fracking job can take from 2 to 6 million gallons of fracking fluid. The largest components in fracking fluid are water and sand. The sand is used to hold the fracture open. The rest of the ingredients are a mixture of chemicals designed to enhance gas and oil recovery. The Environmental Protection Agency is currently studying the environmental impacts of the hydrofracking process on both air and water quality. There are potentially many water issues associated with gas extraction from the Marcellus. These issues include drinking water protection, withdrawal of large volumes of water for the drilling and fracking process, possible contamination of water resources from the fracking process, adequate treatment or disposal of wastewater, floodplain management, and development and enforcement of regulations. All of these issues have ramifications for both water quality and quantity. This module addresses potential impacts on drinking water supplies in particular. The first issue a landowner may notice with gas well drilling is sediment pollution from earth-disturbing activities like road, drill pad, and pipeline construction. These kinds of activities lead to increased erosion and sediment transport, which may pollute waterways. These activities should be accompanied by erosion control practices that, when properly implemented, are designed to protect surface water. Some effective erosion control methods include filter fences, sediment traps, and vegetation buffers, as well as hay bales, culverts with energy dissipators, and rocked road entrances. Enforcement agencies and regulations vary by state. Landowners should watch and report any problems they see in streams and water bodies that flow through their property once drilling activities begin. We know protecting surface waters also protects groundwater because surface and groundwater are connected. The legislation responsible for surface water protection can vary to some degree from state to state. Some states have entities associated with specific rivers, river basin commissions, that are engaged in surface water quality monitoring and protection. Depending on the setting and status of a given drilling project, surface water protection can take the form of elaborate erosion and sedimentation plans to various permitting requirements and to site restoration planning efforts. Surface water monitoring near hydrofracking sites is currently performed by many entities, from volunteer networks to state agencies to university researchers. In Pennsylvania, the Susquehanna River Basin Commission has established a real-time stream monitoring network and do make that data available via the internet. The red areas on the map show locations within the Susquehanna River Basin where monitoring station is in place, and the blue areas are under review as possible monitoring locations. In Pennsylvania, gas drillers are required to have a 300-foot setback from a stream that shows up on a U.S. Geological Survey map, also known as a blue line stream, or 100 feet from a wetland larger than 1 acre. In addition, a 500-foot setback from a well, cistern, or other drinking water supply is required. These setbacks are currently applied in Pennsylvania, but they are under discussion and may be subject to change. Surrounding states that are experiencing Marcellus drilling activity are in the process of developing their own regulations. Consult with the agency enforcing regulations for hydrofracking in your state to find setback distances. These agencies are listed by state in the reference slides near the end of the presentation. Please realize they may be subject to change. As mentioned previously, well drilling and fracking operations can consume as much as 6 million gallons of water per gas well. This depends on the depth and length of the well and the character of the formation being drilled. Access to water on private land is controlled by the landowner, but typically the state or river basin commission regulates water allocation. In Pennsylvania, the Susquehanna River Basin Commission and Delaware River Basin Commission regulate water withdrawals in those watersheds. But in Ohio and in western Pennsylvania, there is no basin commission. The rest of western Pennsylvania is regulated by the Pennsylvania Department of Environmental Protection. Water is a renewable resource, cycling through the water cycle. With hydrofracking for natural gas, though, there is essentially loss of water, meaning that water used in fracking is sometimes injected into the earth deep enough to effectively be removed from the water cycle. While some of the water used for drilling and fracking in deep formations will not return to the surface, some will. This return or produced water must be disposed of somehow. The water can be injected into permitted deep wells for disposal, or it can be treated and discharged. In either case, the water must be hauled away from the drill site. The composition of the wastewater produced after a well has been fracked is highly variable depending on the mix of chemicals used in the fracking fluid and the geology of the rock formations into which the fluid is injected. Wastewater may include sodium chloride, high total suspended solids, metals, oil and grease, organic carbon, detergents, sediment, and radionuclides. We do know that the longer the water is underground and interacting with the rock, the more contaminants it will pick up. The treatment of wastewater continues to be a challenge for the gas industry as it expands. Municipal wastewater treatment plants and brine treatment plants lack the capability to remove all the constituents found in this gas production wastewater. Municipal wastewater treatment plants in Pennsylvania have stopped taking Marcellus Shale fracking wastewater. Consequently, much of this waste is being trucked to underground injection wells in Ohio. The picture to the right illustrates the process of deep well injection disposal. Other treatment methods include membrane filtration and distillation. After either of these treatment methods is applied, the effluent can be reused or discharged to a stream. Testing private water supplies before, during, and after drilling activities is a good idea. Keep in mind that any amount of water testing is better than no testing at all, and pre-gas drilling testing is important to legally protect your rights. If the drilling company offers pre-drilling testing, cooperate. Obtain a copy of the results and keep them in a safe place. In Pennsylvania, pre-drilling testing is offered for private water supplies that are within 2,500 feet of a gas well. This is often done a long time before drilling activities, but is typically more extensive than what homeowners can or are willing to pay for. The cost of this testing is often borne by the energy or drilling company. Homeowners can also perform independent third-party testing to establish a baseline and create a legal record of the water quality of the well. This testing is paid for by the homeowner and is the best legal protection. Homeowners should have it done as close as possible to commencement of drilling. Take care that proper water sampling protocols and sample transfer practices or chain of custody are followed. This ensures that no one can challenge the validity of the sample analysis results. Post-drilling testing by the gas company is not done routinely unless ordered by the regulatory agency, but it can be stipulated in a lease agreement or conducted at the expense of the homeowner. Any claimed change in water quality must be documented and reported within 12 months of drilling in Pennsylvania to hold the driller to the presumed liability clause in the regulation. This clause places the responsibility of proving they did not cause contamination on the gas company within 12 months of completion of the drilling. They can still be held responsible after the 12 months, but the homeowner must prove the pollution, usually with pre- and post-test data. Landowners should be aware of the regulations and any time limitations for their state. Again, take care that proper water sampling protocols and sample transfer practices are followed. In Pennsylvania, water test results are legal documents if they're taken through a third party or chain of custody procedure. A state-accredited lab is hired to come to the house and take the sample, not the homeowner or gas company. The water lab personnel will document who had access to the sample from the collection to the lab. Well owners need to read their test results carefully, understand them, and keep the reports in a safe place. Penn State's drinking water interpretation tool can help you understand your water test reports. The list of parameters that one can test drinking water for is almost limitless. So determining what constituents to test for can be challenging. This slide divides potential tests into 3 levels. Tier 1 are critical to test for no matter what. Tier 2 are good additions, and Tier 3 are expensive analytes to test for if contamination or one or more is suspected, then follow through with Tier 3. One advantage of the Marcellus Shale boom is that private water supply owners are testing their water supplies way more than previously. Before the Marcellus Shale boom, nearly half of private water supply owners in Pennsylvania had never tested their water supply. Penn State water research shows that even before Marcellus gas drilling, there were many common pollutants in our private drinking water supplies. Over 50% of the 700 well owners surveyed knew that they had an aesthetic problem with their water, such as iron, which causes orange stains. However, less than 10% of the well owners knew that they had a health-related problem. Many of the health-related pollutants, like bacteria, cannot be seen, smelled, or tasted in water, and as a result, it's important to regularly test your private water supply. Natural gas is made up in large part by methane. Methane can be naturally occurring in the water, or it can get into water as a result of gas well drilling activities. Methane can enter water wells through natural migration or pressure and release of methane along a gas well borehole. Gas well casing regulations aim to prevent methane migration problems. In Pennsylvania, methane is typically detected in 20 to 40% of private water wells and is not considered a health issue. However, it can lead to explosions if methane migrates into a basement or comes out of the water when it enters a house and builds up in an unventilated area. A spark can trigger an explosion. Water wells testing greater than 5 milligrams per liter methane should install a vented well cap. If the water tests greater than 20 milligrams per liter, the well owner should consider installing a methane aeration unit to treat the water. Methane symptoms in water include effervescent water, a bubbling sound in the well, and spurting faucets. Keep in mind that other gases like carbon dioxide can also cause these symptoms. Have your well tested if you experience these symptoms. The gas industry has taken some proactive measures to prevent surface and groundwater contamination. Some companies have installed spill containment systems to intercept leaks on the entire well pad and are using tanks instead of pits for wastewater to minimize spills and leaks. These companies are exploring alternative fracking chemicals, recycling fracking wastewater, expanding the distance from drilling activities for pre-drilling water testing, and developing rapid response teams when problems are reported. All of these are positive steps. Here are some recommended actions that landowners can take to safeguard their water supplies. Landowners should be aware of gas drilling activities in their area, research the rules and regulations for their state, and make a list of contacts in case they experience problems. When planning to lease land, consider having these stipulations in the lease: getting greater setbacks from your water supply, specifying that the driller pay for pre- and post-drilling testing of your private water supply, streams, or any other water resources that may be impacted on the property. Specify that the driller pay for well water flow measurements before seismic testing. Insist on proper retirement of seismic test shot holes. Specify if and how the driller will access any surface water, and request payment if the water on your property is utilized. Landowners should cooperate with pre-drilling well water testing. Arrange to receive a copy of any water testing reports and carefully examine and understand the results. If it is not offered as part of the contract or close to the time the drilling begins, consider third-party water testing on your property. Watch for obvious problems such as sediment, taste, odors, or loss of water, and report problems immediately to both the regulatory authority and the gas drilling company. Gas drilling companies do not want to impact water resources and will be very motivated to stop and remediate any problems that are identified, especially if they are directly responsible. Most importantly, all leases and agreements should be reviewed by a gas and oil attorney before you sign anything. Content for this presentation was gathered from these references. These sources provide basic information on Marcellus Shale, hydrofracking, water quality, and volunteer monitoring networks. These resources are available to answer your questions for your specific state, including Pennsylvania, West Virginia, New York, and Ohio, Maryland, and Virginia. Sources for each of the pictures shown throughout the presentation are given on this slide. Thank you for listening to this presentation. For more information, please visit either of the following links, and thank you for your time and attention.